Whenever I²C protocol is used as serial bus interface with different voltage domains, the application of voltage translators and repeaters becomes a necessity. My name is Burkhard Laue and I'm Application Marketing Manager here at Nexperia, and together with my colleague Nima Lotfi, we are going to introduce our I²C Autosense level translators as well as our new I²C repeater.
I²C is a two-wire serial bus interface between a master device and one or multiple slave devices. There are two bidirectional signal lines. One is the data signal, SDA, and the other one is the clock signal, SCL. The latter one is always generated by the master device. Since the bus has an open drain topology, pull-up resistors are required for both signal lines. In the idle state, both lines are pulled high. I²C supports write and read operation, which are always started by the master device. Both devices introduce a capacitance to the respective bus line. The bus capacitance can be described as the sum of the capacitance of the master device, the PCB, and the slave device. The more and more slave devices are added, the higher the bus capacitance gets. For 100 kHz and 400 kHz operation, the bus capacitance is limited to 400 pF, and for 1 MHz operation to 550 pF. An example for high bus capacitance in an I²C application can be seen in these scope traces. The high steepness of the falling edges is due to the active drive of the open drain stages, whereas the rising edges show an exponential capacitive charging curve.
With an active buffer or repeater device put into an I²C bus with high bus capacitance, the overall capacitance is split up, resulting in improved signal integrity and power efficiency. Additionally, it is often the case that the master device and the slave devices do not operate on same voltage levels, which calls for a voltage translating device. Nexperia Autosense translators with pass transistor topology come in two families. The LSF10X is a cost-efficient solution which supports voltages down to 0.95 volt and up to 100 MHz. The NXS010X enhances rising edges, allowing higher bus speed for high capacitive bus load with decent pull-ups, improving power efficiency. The NCA9701 is an open drain I²C bus repeater for the clock and data line with acceleration of the rising edges. Two fully symmetrical supply voltages enable translation in the range from 0.9 volt up to 2 volt. The feature of edge acceleration is realized at the A side as well as at the B side. Integrated pull-up resistors are present in the IC. The NCA9701 device is suitable for I²C bus standard mode to fast mode plus and supports clock stretching of slave devices.
But how does a repeater improve the actual I²C communication?
Let's have a look at data reception at the master device. We start with an ideal I²C bus which has no bus capacitance. In a real application with slow rising edges, the data setup time becomes comparably short. Using a traditional repeater increases the steepness of the rising edges and enlarges setup time. This improvement is called setup time gain and defined as setup time of the data repeater minus the setup time of the direct link.
Looking at an I²C waveform with rather long rising edges, how can this be speed up, Burkhard?
One possibility is to reduce the pull-up resistors, which will charge the line capacitor faster.
But this will require a more powerful driving stage to achieve the valid load level and of course will deteriorate the power efficiency of the interface.
Correct, Nima. This is why we better change the charging characteristic and use edge acceleration. The edge accelerators in the NCA9701 are controlled current sources, which are implemented at the input side as well as at the output side. Charge characteristic will change from exponential to linear.
Will the setup time gain benefit from this implementation?
Yes, it does. The data setup time with the NCA9701 is much longer compared to traditional repeaters because the edges become steeper. In addition, rising edge acceleration for the output starts immediately once the input has passed the trigger. At this point, high state is detected at the input, leading to immediate acceleration at the output. Edge acceleration is performed until the signal reaches the stop. The NCA 9701 provides data setup time which is longer compared to traditional repeaters. Setup time gain has been improved further.
For in-application validation of the NCA 9701, we developed an application board featuring integrated master and slave devices, supporting flexible voltage scenarios through different LDOs, and additional LSF0102 at A and B side. Optional open drain stages allow standalone testing of the single channels. Interfaces for external master and slave devices are provided as well. The zoom of the oscilloscope trace visualizes the operation of the edge accelerators.
For more information, please check out our whole portfolio of Autosense translators and repeaters.
And don't forget to visit us at Nexperia.com.
Thanks for watching.